Credit classification for lenders, portfolio analysis using Python, Part 1 continued. Portfolio analysis. Portfolio analysis is a critical tool for lenders as it allows them to understand the risk profile of their portfolio, identify high-risk and low-risk segments, and assess the impact of credit classification on portfolio performance. This can help them make more informed decisions about future lending and manage risk more effectively. Analyzing the portfolio data. Portfolio analysis is the process of reviewing a lender's loan portfolio to understand the risk profile of different credit categories. This may involve reviewing the credit scores, credit histories, income, and debt-to-income ratios of borrowers in the portfolio, as well as the types of loans and their performance. By analyzing this data, lenders can understand the risk profile of different credit categories and identify any areas of the portfolio where there is a higher concentration of risk. Identifying high-risk and low-risk segments. By analyzing the portfolio data, lenders can identify high-risk and low-risk segments of their portfolios. High-risk segments may include borrowers with low credit scores, short credit histories, or high debt-to-income ratios. Low-risk segments may include borrowers with high credit scores, long credit histories, and low debt-to-income ratios. Assessing the impact of credit classification on portfolio performance. Lenders can use portfolio analysis to assess the impact of credit classification on portfolio performance. This may involve analyzing the default rates, delinquency rates, and loss rates of loans in different credit categories, as well as the return on investment. By understanding the performance of different credit categories, lenders can make more informed decisions about future lending and take steps to improve portfolio performance. I. Data collection and cleaning. A. Data sources for credit classification. Data can be sourced from publicly available datasets from financial institutions and credit bureaus, application programming interfaces, APIs, for data retrieval, and data from social media and other unconventional sources. Publicly available datasets from financial institutions and credit bureaus are commonly used as data sources for credit classification. These datasets provide information such as loan amounts, interest rates, credit scores, and other relevant borrower information. Application programming interfaces, APIs, for data retrieval are another source of data for credit classification. APIs provide direct access to financial institution databases and credit bureau data, allowing for up-to-date and accurate data retrieval. Finally, data from social media and other unconventional sources can also be used in credit classification. B. Cleaning and pre-processing data. Cleaning and pre-processing data is an essential step in credit classification. Data cleaning involves identifying and removing duplicates, dealing with inconsistent and erroneous data, handling missing data, and encoding categorical variables. Duplicates can skew the results of the credit classification model and must be removed. Inconsistent and erroneous data can arise due to data entry errors or other factors and must be identified and corrected. Missing data can be handled through imputation techniques, such as mean imputation or regression imputation, or through the deletion of missing data. Categorical variables must be encoded into numerical values that can be used by the classification model. Identifying and removing duplicates. One way to identify and remove duplicates is by using software or programming tools that can detect and flag duplicate records based on certain criteria such as matching values in specific fields or matching patterns in text data. For example, Excel has a built-in feature to detect duplicates and remove them. Another option is to write a script in a programming language like Python for our case, to identify and remove duplicates from large datasets. Dealing with inconsistent and erroneous data. To deal with inconsistent and erroneous data, one approach is to manually clean the data by identifying errors and inconsistencies and correcting them one by one. However, this can be time-consuming and may not be feasible for large datasets. Another approach is to use software tools that can automatically detect and correct errors and inconsistencies, such as spell checkers or data cleaning libraries in Python or R. It's also important to establish standards for data collection and entry to prevent inconsistent and erroneous data in the first place. This can include developing clear guidelines and training for data entry personnel, using automated data validation checks, and conducting regular audits of data quality. Handling missing data. A.
Imputation techniques.
Imputation techniques are used to fill in missing data with estimates. Some common techniques include mean imputation, median imputation, mode imputation, and regression imputation. B.
Deletion of missing data.
Deletion of missing data is the process of removing observations that have missing data. There are two types of deletion methods. Listwise deletion, which removes entire observations that have missing data, and pairwise deletion, which removes only the missing values. Encoding categorical variables. A.
One-hot encoding.
One-hot encoding is a technique that creates a binary variable for each category of a categorical variable. Each variable represents whether the observation is in that category or not. For example, if a categorical variable has three categories, A, B, and C, one-hot encoding would create three binary variables. A equals 1 over 0, B equals 1 over 0, and C equals 1 over 0. B.
Label encoding.
Label encoding is a technique that assigns a numerical value to each category of a categorical variable. For example, if a categorical variable has three categories, A, B, and C, label encoding would assign the values 1, 2, and 3 to the categories, respectively. Label encoding can be useful when there is a natural ordering to the categories, but it may not be appropriate for categorical variables without an inherent order. Thank you for watching.